So in this lesson, we're going to talk about the fundamental trig identities. And there are quite a few trig identities, but I only want to go over a couple of them. I need to save something for your pre-cal teacher. So first, we'll talk about the reciprocal trig identities. And these are expressions that can be substituted into other expressions. So if you see sine theta, you can convert that to 1 over cosecant theta. Or if you see cosine theta, you can convert that to 1 over secant theta. Tangent theta, well, it's the same thing as 1 over cotangent of theta. And then by definition, we know that cosecant is 1 over sine, and secant is 1 over cosine, and cotangent is 1 over tangent. So these are called the reciprocal identities. So if you're going to prove something with trig, you can always use your reciprocal identities. Two other trig identities are the quotient identities, tangent of theta being defined as sine over cosine, and cotangent of theta being defined as cosine over sine. And these are quite useful. You can use these to replace tangent and cotangent all the time. And then my favorite of the trig identities, the Pythagorean trig identities. Basically, it takes our trig functions and puts them into context with the Pythagorean theorem. So sine squared theta plus cosine squared theta equals 1. This trig identity shows up a bajillion times, so make sure if any of the trig identities you're gonna, put into your memory, that's the one. Okay, sine squared theta plus cosine squared theta equals 1. And you can use this one and the other trig identities we've seen to get this next Pythagorean identity. It's 1 plus tangent squared theta equals secant squared theta. And then 1 plus cotangent squared theta equals cosecant squared theta. So these three form the Pythagorean identities. One way to use the trig identities is in proof. I can give you a statement involving trig functions, and you can use the trig identities to prove it true or false. And to look at a basic kind of proof, if I just ask you to transform the left side to the right side, it's kind of like you're proving but without the justification. If you add the justification like, oh, I used the reciprocal identity, then that's a proof. So I'm just going to show you a very basic example. Working with the trig identities was one of my favorite things in pre-cal because I thought of them as like little math puzzles and you had to make sure they work. Now, the thing is with these trig identities and with proof, you have to turn one side into the other side. Now in this case, I'm specifically telling you to turn the left side into the right side, and in this case it's obvious because the left side has more to give us than the right side. Now when you do a proof of one of these trig statements, you have to convert one side to the other side. You can't work both sides, okay? Now in doing this, there are several approaches, right? Realizing that tangent and cotangent are quotient identities, and I can substitute sine of theta over cosine of theta for tangent, and cotangent can be substituted as sine theta or cosine theta over sine theta, and then through the miracles of cross cancellation, I get 1. Now that's not the only way to show the transformation from the left side to the right side. The other way is to realize and use the reciprocal identities. So I know tangent theta is just tangent theta, but cotangent can be replaced by 1 over tangent theta by the reciprocal identity, and then therefore those two cancel, and I get left with 1. And so that's how we can use our identities to transform one side into the other side and eventually prove things.